Hey everyone, Justin DUNNICLIFF, the Hacks Program Manager for the National Security Innovation Network. Welcome to the Hacks Program's first open online challenge. If you haven't already, I recommend that you watch our challenge intro video linked here in the description below. There's a few more logistical items that you might find helpful. You're here today to learn about dense urban environments and the challenges that military operators and emergency first responders face in trying to achieve situational understanding in these areas. Why should you care about that? Well, think about this. By 2050, nearly 7 billion people are projected to live in urban areas. To put that into context, that's almost twice as many people that live in cities right now. And what would be like if nearly the entire world population today moved to an urban area. This expansion means that population concentrations in existing megacities like New York will increase, and entirely new megacities will come into being. Thus, the likelihood of having to conduct operations, fight fires, or rescue people in a dense urban environment is increasing each year. Said differently, it is happening right now, it is going to continue happening more tomorrow, and we need your help to do it better today. Hopefully, you've already read the challenge or heard me say it in the previous video, but if not, here it is again. Develop a system or component of a system to collect information about an interior space, transmit data to frontline operators, emergency responders, and command and control teams, interpret the data, and present actionable information in an intuitive manner to the operator in the time frame of hours, minutes, or seconds. In this case, faster is better. Sounds simple, right? With that, I'm going to hand it over to two subject matter experts who can explain much better than I can why it is imperative for you to respond to this challenge. In the next few minutes, you're going to hear from Captain Elijah Bales from the Army 75th Ranger Regiment and Mr. Bob Hesse from the Combat Capabilities Development Command and the technical lead for the Army Subtraining and Dense Urban Environment Community of Practice.
With 68% of the world's population expected to live in urban areas by 2050, emergency responders and U.S. and allied militaries will likely engage in future crisis response and military operations in dense urban environments. These areas present specific challenges for leaders at every level due to their complexity, density, and interconnectedness, congestion caused by the number of people, vehicles, buildings, and electronic devices, and the amount of unknown terrain, both horizontal and vertical, interior and exterior. Examples of complexity pertaining to this specific challenge include the unknown, unknowable, and constantly changing, the density of structures and limited line of sight, physically and mentally challenging to operate within, cannot readily achieve situational understanding, congested, contested, and constrained, cover and concealment for adversaries and criminals, separation of units, warfighters, and supporting capabilities, interconnected and embedded threats, and vertical, horizontal terrain and threat.
Although the dense urban environment presents additional challenges and complexities, the formula used by leaders and operators does not change. The most important factor in any and all environments is situational understanding. Situational understanding is the perception of the elements in the environment within a volume of time and space, the comprehension of their meaning, and the projection of their status in the near future. Providing information quickly and accurately in a form that allows leaders to visualize it greatly increases situational understanding. This increased situational understanding results in more informed decisions and reduces the risk to first responders and military operators. As a leader in the military, this image is representative of many things. It is representative of the threshold of our current situational understanding. It is representative of where we currently lose organizational control, and it is representative of the most dangerous part of every operation. Sending operators across that threshold into the unknown is the riskiest thing we ask of soldiers. In the past, in order to gain situational understanding, humans were used as sensors. They were the most reliable and provided the capability to perceive the environment, comprehend its meaning, and then make decisions. This has resulted in the front lines being defined where humans were physically located. And in a dense urban environment, this usually led to chaotic and bloody fighting with non-combatants regularly present. Since World War II, a lot of technology has been developed to help provide situational understanding. Currently, all of that technology is able to provide good understanding of the environment external to a structure, but there is still a lack of understanding internal to structures. This is in part because the technology does not provide accurate information fast enough and in a way that leaders can easily visualize it. This results in humans being used as sensors internal to a structure. In the future, we need computers to do computer things and humans to do human things. In order to change the way we look at internal structures, we need technology to perceive the internal environment, understand what is present, and communicate that in an intuitive way to humans. This will allow leaders and operators to use all of their bandwidth doing what humans can do best, making decisions in chaotic environments.
Tactical formations in decentralized or isolated dense urban locations will be overwhelmed and limited physically and visually to predict and determine their next move, relying on intelligence formations to develop, leverage, access, and disseminate relevant data, such as geospatial, infrastructure, and information, towards an integrated, spatially accurate, three-dimensional intelligent agent to synthesize, anticipate, and distribute actionable information to the tactical formation. Maintaining situational understanding, it's exacerbated due to the density of dense urban environments, and specific to this challenge are subterranean environments such as subways, sewers, basements, and the interior spaces of buildings, such as floors, hallways, rooms, basements, limiting communications, navigation, sensing, and maneuver, increasing vulnerability to tactical movement. Standoff collection of actionable information from personnel, ground and air ISR assets, masked by terrain, specifically interior spaces, as well as line of sight obstructions from the density of structures do not currently exist. Currently, this relies on human and/or limited robotic platforms to obtain entry and perform sensing to obtain information collection, putting soldiers and first responders at risk. Elimination of operator control units, such as remote control of the systems towards AI, machine learning, is the leap from first orientation and survey of surroundings and interior spaces to understand and self-determine waypoints to interior space entry points, self-navigation, sensing, and dissemination of information based upon the geometric complexities. Providing timely and accurate, but perhaps episodic ISR via AI or remote autonomous systems and dispersed sensing assets across multiple dimensions may be beneficial to only collect information in certain temporal or spatial windows versus always collecting. Machine intelligence with dispersed platforms and sensors can be trained to understand patterns and fill knowledge gaps on when to collect based on observation, behaviors, and the exploitation of time. Topics to consider when developing your solution. The ability to have unfettered capability for situational understanding in both depth and breadth of the field of view in confined and compressed interior spaces, and the ability to maintain situational understanding in previously cleared spaces. The ability to determine which data layers and elements of sensing are relevant in space and time to achieve situational understanding in interior spaces, obtaining and disseminating relevant data. How best can we rapidly assimilate vast amounts of data into actionable information to support operations? Identify and track friendly movement, enemy forces, criminal movement, and civilian behaviors within and beyond line of sight of interior spaces. Overcome the persistent 360-degree threat and inability to have rapid, positive identification of friend or foe. Providing timely and accurate, but perhaps episodic, actionable information. How our resources are limited. How do you intend to conserve it? Increase standoff and dispersed collection of information of interior spaces, such as rooms, hallways, basements, platforms, and tunnels. Geointelligence to depict physical features of interior spaces, assessing and identifying structural integrity. Enhance the performance of operator duties without excessive, extreme cognitive and physical strain. Standoff sensing and only providing relevant actionable information is key. Man-portable, backpackable, throwable, leave behind, networked, interoperable, collaborative, self-navigating, self-sensing autonomous systems. Dense urban conditions that will impact the capability. Variations in past and modern construction materials, their density and composition to sense through interior or exterior walls, floors, rooftops, platforms, and deep within the interior spaces. The lack of ambient light, may render standard thermal and night vision devices ineffective. The density and persistence of obscurance may increase. Obstacles, to include hazards, are harder to identify. Payloads and sensors that are too large may not be suitable in confined interior spaces. Multimodal, multispectral sensing to maximize information within the various conditions, such as structures, material, density, etc. Many communications simply cannot span and reach upper and lower levels of high-rise buildings and down in subways from the surface. Noisy electromagnetic environment, multiple networks and large number of wireless devices operating over a wide frequency spectrum and in a confined area can cause severe interference. The complexity of terrain and increased density of urban structures can inhibit connectivity of systems and the accuracy of GPS. The composition of structures, walls, and objects can create multipath signal conditions that impair high-frequency signal reception.
You probably heard the challenge statement about 10 times by now, but we're going to review it one more time. As we review the challenge statement, I want you to remember this image. This black door represents the unknown of an interior space. We need your help to inform operators as they prepare to cross that threshold into the unknown. The challenge is to develop a system that can collect information about an interior space, transmit the data to both emergency responders and command and control elements, interpret that data, and present actionable information in an intuitive manner to the operator on a time frame of hours, minutes, and seconds. We need you to develop innovative concepts that allow first responders and military operators to understand at a moment's notice what is going on inside buildings and subterranean spaces. The challenge consists of 4 focus areas. Solutions don't have to address all of these focus areas, but the more a solution integrates them, the more beneficial it will be to the user. The first focus area is sensing physical characteristics. This is defined as understanding the geometry and content of interior spaces. The second focus area is sensing activity, defined as sensing and characterizing occupants and assessing activity. The third focus area is delivering data, and that's defined as the timely transmission of data in usable formats. And the fourth focus area is displaying information, defined as presenting actionable information to responders, operators, and decision makers. Since its formation in 1775, it has been said that the United States Army Infantry has owned the last 100 yards of the battlefield. Throughout America's history, soldiers have accomplished the country's foreign policy by facing its enemies bayonet to bayonet. While the close quarters nature of combat will be inherent in all future conflict, we have the opportunity to change that paradigm now. We need your help developing novel solutions that will change the way first responders and military operators fight their enemies in the future.